Okay, so we've practiced finding oxidation states and we're reasonably sharp at that, I hope. So why do we care about them? Because sometimes you get a reaction like one of these where you think there may have been an oxidation or a reduction, but it's not totally clear which. None of these reactions contain electrons to make it clear for us. So what you have to do in that case is look at the oxidation states of the atoms inside and see if they've changed, and if so, did they go up or down? Up means oxidation, down means reduction. So let's take these apart and see what's going on. Arsenic and 3 oxygens. The oxygens bring a total of -6, but the total is only -1, so this arsenic must have an oxidation state of +5. Over on this side, the oxygens bring -4, so the arsenic must be +4. So the thing to notice here is that the oxygens did not change. They were -2 the whole time. But the arsenic went from +5 down to +4. If your oxidation state goes down, that means it was reduced. That means this reaction is a reduction. And for this to happen, there must be electrons coming in from someplace to account for the changed state of the arsenic. Here we have permanganate. The total charge from the oxygens is -8. But the total on the ion is -1, so the manganese here must be worth +7. Over on this side, the oxygens are bringing a total of -4, so the manganese is +4. Manganese went from +7 down to +4, reduction again. It's a reduction if your oxidation number got reduced. Hydrogen peroxide to oxygen. Well, hydrogens are +1 pretty much always. Oxygens are usually -2, but not in a peroxide. In a peroxide, they're -1 each. So I'm going to put -2 or -1 each. And in oxygen, the oxidation state is 0. So we don't know what happened to the hydrogen. They aren't showing it here. We'd have to balance this by half reaction if we wanted to find out. But clearly the oxygens went from -1 each to 0 each. Their oxidation number went up, because from -1 up to 0 is an increase. So that reaction is an oxidation. Ethanol, what's happening here? Hydrogens are +1, and we have a total of 6 of them. I'm just going to write +6. The oxygen is -2. Now the total for this whole molecule is 0, so what's going on here? We have 6 -2, we're at +4 right now. The carbons together must be bringing a charge of -4, which means they're -2 each. Over on this side, carbon dioxide, we have -4 from our oxygens, so the carbon, just one of them now, must be +4. You could also write +4 each, but when there's one atom, that's a bit redundant. So the carbons went from -2 all the way up to +4 per atom. Definitely oxidation. Large amount of oxidation. Ammonia, let's see, +4 from the hydrogens. The total is +1, so nitrogen must be worth -3 here. And over on this side, if oxygens are -2 apiece, that's -10. So the nitrogens must be +10 total, or +5 each. Nitrogen went from -3 up to +5, massively oxidized. This is oxalate, probably. Oxygens -8, -2 each, total of -8. From there we have to get up to -2, so the carbons must be bringing +6 or +3 each. On methane, we have +4 from the hydrogen, so the carbon must be -4. Carbon went from +3 per atom to -4 per atom, reduced. CrO3+, I don't know what to call that. -2 for the oxygen. The chromium must bring us from -2 up to +3, so it must be worth +5 over here. Then we have dichromate. 7 oxygens is a total of -14. To get from -14 up to -2 is a total of +12 from the chromiums. But there are 2 of them, so they're bringing +6 each. The chromium went from +5 to +6, so that's a slight oxidation. H4IO6, we have -12 charge from the oxygen and +4 from the hydrogen. Technically, I should have done the hydrogen first, but it's okay. The iodine is where the real questions are going to come up. What are we at now? +4 minus 12 puts us at -8, but the total is only supposed to be -1 according to this, so the iodine must be +7. And on this side, pure iodine has a charge of 0. So the iodine went from +7 down to 0. It was reduced. And finally, gold in pure element form has an oxidation state of 0. And now we have gold cyanide. The cyanide ion overall has a charge of -1. You can look it up on the polyatomic ion list. There are 4 cyanides, so these collectively are bringing a charge of -4. But the total is only supposed to be -1, so the gold here must be +3. Gold went from 0 up to 3. That would be an oxidation. Good. This next set is the same idea. You have to find, here we have one substance being oxidized and one being reduced, because that's what a redox transaction is usually about. So we have to figure out which one's which, and this means more oxidation numbers. So let's see if we can do these at high speed. 0, -6 from the oxygen, the nitrogen must be 5. Oxygens are -4, the tin must be 4, and -2 for the oxygen, the nitrogen must be +2. So tin, just paying attention to tin's story for a moment, tin went from 0 to 4. That means tin was oxidized. And if you got oxidized, it means you are the reducing agent. Right? If you were oxidized, that means the other guy oxidized you. The other guy is the oxidizing agent, so you must be the reducing agent. That's a bit of a brain twist the first couple times you think of it, but you're about to hear it 8 times, so I think you will get used to it. The other story is nitrogen, which went from 5 down to 2. So nitrogen was reduced, which means it must be the oxidizing agent. With these side by side, it might make sense. Tin got oxidized. Well, who did that? Must be the other guy, the nitrogen. Nitrogen is the oxidizing agent. Nitrogen got reduced. Well, who did that to him? The other guy, the reducing agent. Let's see if we can make that work a few more times. Chlorides are -1 each, total -4. The lead is +4. Oxygen's -2, we knew that already. Chlorines are -2 or -1 each, total of -2, so the lead is +2, and pure oxygen is 0. So if we just look at lead, it starts at +4, it drops to +2. Lead was reduced. If you got reduced, then you are the oxidizing agent. And if we look at chlorine, chlorine started at -4 over here. Oh, wait, sorry. The chlorine doesn't change, does it? The chlorines were -1 each on this side, and there's still -1 here, so I'm up the wrong tree going after chlorine. The oxygen is where the other side of the story. The oxygen started as an oxide ion with a state of -2, and then it goes to 0. So oxygen got oxidized. Unusual. And if it got oxidized, then it is the reducing agent. Normally oxidation is something that oxygen does to everybody else, but in this case oxygen was oxidized by another chemical. That's rare and might have meant that they had to cheat, but it can be done. Okay, iron 3, that one's self-evidently +3. What's going on with this? NH3OH. The hydrogens are all +1s, so we have +4 coming from our hydrogens, -2 from our oxygen. That puts us at +2. But the total is only +1, so this nitrogen must be worth -1. Fair enough? I'm assuming by this point that you're feeling good about oxidation states, so I'm doing them a little faster. This iron's +2, of course, and here the oxygen's -2, so the nitrogens must be total of +2 or +1 each. So what are the stories in this? Iron, of course, went from 3 down to 2. So iron was reduced, which means it must be our oxidizing agent. And what else changed? Nitrogen, green. Nitrogen started at -1 and went up to +1. So nitrogen was oxidized. And if you got oxidized, you are the reducing agent. H3PO2, that's not... PO4 would not surprise me, but this does. Anyway, -4 from the oxygens, +3 from the hydrogens puts us at -1, so this phosphorus must be +1. -14, we have to get up to -2, so +12, +6 each. Here we have -8 and +3, so we're sitting at -5. The phosphorus here must be +5, and chromium here is, of course, +3. Who changed? Phosphorus went from 1 up to 5. So phosphorus was oxidized, meaning it's our reducing agent. And chromium went from +6 here to only +3. Chromium was reduced. And if you got reduced, you're an oxidizer. All right, we have some kind of vanadium complex here. This is -4 from oxygens. We have to get up to +1, so this vanadium must be worth +5. Tin is +2. Here we have an oxygen giving us -2, but our total is +2, so the vanadium must be +4. And the tin is 4, of course. Vanadium started at 5 and fell down to 4. So vanadium was reduced, which means it's our oxidizing agent. And the other thing that happened was tin went from 2 up to 4. Up from 2 to 4 means oxidized, and if you are oxidized, you got oxidized, therefore you reduced the other guy. Here we have pure hydrogen is 0. -8 total from the oxygens, so each nitrogen must be, the nitrogens must be +8 or +4 each. Water, we have -2 from the oxygens and +1 each from the hydrogens, and nitrogen is 0. Who changed? Hydrogen here went from 0 up to 1. So hydrogen was oxidized, which makes it a reducing agent. And who else changed? Nitrogen started at 4 and fell to 0. Nitrogen was reduced, so it's our oxidizer. Oxygens minus 2 each, so total of -4. But we need to get up to -1. That's the ion total, so chromium must be +3. 8 oxygens is -16. To get us up to 0, these two must be +16 or +8 each. -8. -2 each from the oxygens, total of -8. To get us up to -2, this chromium must be +6. And in sulfate, we have -8 from all the oxygens. To get up to -2, this sulfur must be +6. Who changed? Chromium went from 3 up to 6. Chromium was oxidized, so it's our reducing agent. What else changed? Sulfur went from +8 down to +6. Sulfur was reduced, which makes it an oxidizing agent. And last one, we have xenon trioxide, -6 from the oxygens total, so the xenon must be +6. Iodine's -1, it's a monatomic ion. Pure xenon has a charge of 0, and pure iodine has a charge of 0. So the changes are xenon went from 6 down to 0. Xenon was reduced, which makes it an oxidizing agent. And iodine went from -1 up to 0. So iodine was oxidized, which makes it a reducing agent.